welcome you all for one more edition and also to see an opportunity to talk to experts and technology experts is always an opportunity. So 3D Graphy News, ladies and gentlemen, as you all know, that we've been a catalyst in being an information source for 3D technologies across various different technologies. So 3D technology per se constitutes of 3D printing, 3D visualization, 3D scanning, 3D software, 3D simulation, AR and VR, as I mentioned, 3D visualization is also going to complement each of these technologies. Scanning, as also I had mentioned, but more importantly, also materials, because more the materials and more development research happening in this space means that becomes more conducive for the end user to look at options. So 3D printing is also called additive manufacturing. The conventional method is subtractive manufacturing. So we have now two brothers of the same daddy, but they work in different, they are different technologies. So subtractive is the conventional method, which is the CNC, and we also use CAD to see that the ultimate objective is met with, and machining. But the 3D technology, the 3D printing space, that is also additive manufacturing, is called that's also 3D printing and additive manufacturing. So here is a possibility that we look at for customized manufacturing. So sectors like aerospace and defense, automotive, to much of an extent, though there much of the reliability is on subtractive manufacturing when it comes to injection molding and various other means and methods. But now the trend is also gaining some traction when it comes to smaller inventories like EV for electric vehicles. So people are looking at that as an option also. And we believe that mass customization is going to be the future, because every design, every construct is going to be tuned to what the end user is expecting, because that choice was not there, but now we have that as a choice. And then not to forget about dental and medical, which is also one of the key aspects in terms of implants and also reconstruct in surgery, where now you can have mandibles and restoration for your orbital floor and zygomatic arch. All of that can be done with 3D printing in medical space and also in orthopedics. Orthotics and prosthetics, another area in the medical space, is also gaining a lot of traction. So materials are going to be very, very essential, be tuned to what is required. But 3D printing as a technology can do what is required. So creating imagination and making it real is a possibility today. So we also know about 3D printing houses to an extent that we know that it was just an imagination, but now it is a reality. So today I have an opportunity to introduce you to a manufacturing setup which is actually based in Chennai, and the founder of this company, Mr. Dhinesh Kanagaraj, who is the CEO and the founder, and he is one of the key respondents for today's interview, and we will want to understand and learn his expertise in terms of, and also his journey, where it all started. So this is an indigenous machine manufactured in India, and thanks for the new initiative by the Government of India on Make in India and Atmanirbhar Bharat. So all of these will also help and constitute to the help and support of indigenously manufacturing companies in the country, which means we are also trying to create a level playing field to our manufacturing setup here, and I'm sure the future is bright. So, but here is also a possibility to see that how these manufacturing setups and companies can also have exports going forward. So that's where the larger context of how the country can also benefit, but the consumption is much bigger in terms of the opportunity in the country itself. So thank you so much, Dhinesh, for your time. It's a pleasure to have you on board, and we are really proud of indigenously manufacturing. I mean, a company who is indigenously working hard to create these products uniquely. And what I understand from your technology is that you are actually a carbon fiber machine-based technology with 3D.
Yeah.
So, let me know, how was your journey, Dhinesh, and where it all started, and why 3D, please.
Yeah. Thank you, Dr. Shibu. Thanks for a warm welcome, and thanks for inviting me to be part of this event as well. So let me just give a quick introduction about how I essentially started. So I come from an aerospace background. I did my BTech in aerospace from IIT Madras, and then after that, I worked with ISRO for a couple of years actually. So I have been kind of a proper aerospace engineer for quite some time actually, and we have worked with a lot of lightweighting technologies, lightweight structures, high performance structures, part of our aerospace curriculum as well as part of my professional experience as well. And here we use a lot of very high strength advanced materials like carbon fiber, glass fiber, Kevlar, and these kind of fiber reinforced materials essentially. And that is essentially where my introduction to these materials came into picture. And in very early times during my internships at NAL and HAL, during my college times, I came to see that most of these are still handcrafted today. You look at, say, plastics or metals, there are several other technologies like stamping or injection molding and several other very high, fast manufacturing processes. But if you look at, say, carbon fiber, for example, most of them are done by completely manual process, almost like pottery, how pottery is done. And there are a few automated technologies, but you cannot get very complex geometries out of those kind of automated technologies. A lot of limitations. And I saw the same kind of challenges during my time in ISRO also. And that is where the passion came to automate this manufacturing process for this materials itself came into picture. And when then I quit ISRO and then we started looking at various ma- sorry, manufacturing technologies towards automating the manufacturing process for these materials. And 3D printing came as a very normal choice because most of these materials are even traditionally done by additive manufacturing process. Like if you look at how manual process is done, they take a fabric layer and then they deposit that layer, they stick it, and then another layer of carbon fiber is stacked on top, another layer of carbon fiber. So even manual process, they do a very additive manufacturing process. And so it looked like using an additive manufacturing method of automating it is a kind of a very natural progression itself actually. And if you ask me, I would say that additive manufacturing came out of composite industry itself. Kind of like layer by layer manufacturing of plastics. Kind of is how composite industry has been working since it was brought up, since it was born. And so it is a very natural thought process for us in this industry to consider 3D printing as a very natural choice. That is kind of how we started working on this particular field. Yeah.
So I think predominantly it was because you come from an aerospace background.
Yeah.
So you had a vision to see that where you can actually partake and ensure that the gaps can be filled in terms of the choice of the material and the design, in terms of getting the final procurement for. Seeing this as one of the solutions for aerospace industry. Which are the industries other than this that you see a prospect and where your machine and your technology is gaining? You're looking at trying to penetrate.
Yeah. So we can look at anywhere you are looking at a high strength material. So a direct application, if you are looking at it right from a composite material, can be like one asset is in aerospace, and a lot of use cases are there in defense and shipping industry also. Like then shipping, because these are much better corrosion resistance compared to metals. This is a very obvious choice in the shipping industry also, and even in biomedical use cases also. Like you take implants for example. Carbon fiber is a much better organic material compared to titanium, which is presently used in most of the implants. And this is already medically proven material for very better grade of implants compared to titanium based implants also. And the other use cases can be like large wind turbine blades are these days made out of carbon fiber, lot of sports industry and high performance racing industry, satellites, and there is a huge amount of use cases, but they typically tend to be a little on the expensive side of things. And the other side of looking at it is anywhere you are looking at slightly high strength 3D prints. So most of the 3D prints tend to be not so strong compared to say injection molded plastics. They are not as strong as those. So, but if you want just a little bit of that injection molded strength, but you want to do it out of 3D printed parts itself, you can actually consider, say, just to use 20% of continuous fiber materials in your overall 3D print. So the overall cost doesn't go up like you do with a 100% continuous carbon fiber 3D printing. So you can just introduce say 5% or 10% of carbon fiber in your overall product. That itself will be giving you the amount of strength as much as an injection molded component. So anytime want to use a plastic component, a 3D printed plastic component itself in your use cases, but you want the same strength of an injection molded part, even those kind of use cases also, you can actually use carbon fiber based 3D printing. But you don't have to go for 100% carbon fiber, as I said. You can just look at, say, 10% of continuous fibers or 20% of continuous fiber based on the strength required. Yeah.
So which means you can actually have a good combination of materials and the structure of the processes when it comes to manufacturing in terms of supporting both, wherein both can be taken into consideration.
So it can be used in any area that polymer area supports, as well as specialized composites area also.
Okay. So polymer being the key area. Is there anything that you also looking at the metal side? If the machine can actually, now that we know that FDM fuel deposition can also, metal can also be manufactured. Are you looking at that kind of a scope also, or we would want to build on here from here when it comes to carbon fiber? I think the tensile strength is also much same in compared to metal. But I'm just thinking, I mean, are you also looking at evolving with time with various other materials, or what are the different? Or let me ask you, what are the different materials, Dhinesh, apart from carbon fiber that you are actually correct?
So the machines that we have launched right now can handle all the polymers and the fiber reinforced polymers. So that is the machines, that are the materials that we can handle right now. But in future, we are not looking at just say plastics or fiber reinforced plastics alone. We can look into metals also. The way how we are looking at it is like even metal is part of composite structure. So we want to have a 3D printer. Like if you want particular part to be made out of metal, particular part to be made out of plastic, another area to be made out of fiber reinforced, the single unit should be able to do that, deliver that essentially. That is where our thought process is moving towards on a long-term cycle sort of long-term vision sort of. But let's say that will take a couple of years before we do an integrated manufacturing unit system. But for now, in this year and say 2 more years, we'll be mostly focusing our efforts on the composites and the polymer space.
Okay. Also, when it comes to the microns, what is the microns that it can achieve, the machine?
The precision, it can go up to 10 micron precision it can achieve, the repeatability of the machine. The end product precision is up to 50 microns.
Okay. And also when it comes to bed size, you have various different series, Dhinesh, in terms of the industrial printers, or I would say production printers, and then probably even for prototypes. So have you...
So off-shelf machines we have that cater to 325 cross 325 cross 325, so a little 1 foot cube sort of. That is our off-shelf machine, which we'll always have a stock of. And we do take up custom machines for any bed size also. Like in case you want 500 cross 600 or something of the order, we can cater to that as well. And we have our own pellet extrusion based system that we supply for anything beyond 1 meter scale also. So you want anything very large bed size, like 1 meter bed size or 5 meter bed size, that can be there. We prefer a pellet based extrusion system rather than a filament based extrusion system, because that works out better on the unit economics and the lead time sort of. And that also we do have a system for pellet based extrusion also.
Okay, okay, that's nice. So that gives your scope and the coverage on a very large spectrum in a way. Yeah. So I think automobile, maybe they would probably need these for their bonnets, as in the interiors also, for them to actually make an assessment. Also in terms of for the safety crash test and various other requirements, this can also be of great relevance.
Yeah.
So
and these large pellet extrusion, another area of use case we have had several clients coming for is in terms of large tooling applications also, especially in the composites industry or the aerospace industry, wherever they require very large tooling, also has been a very big go-getter for us in the large scale pellet extruder system. Yeah.
Great. So now that we know that the product has a great potential, Dhinesh, and the kind of research and development in terms of various different materials that you've been able to get out of this particular exercise of your research, what about your penetration in terms of how do you plan to, or you might already have a strategy in terms of setting up as in partnering with resellers. So it's already started. It's been it's a very new launch, right, Dinesh? So how is it structured as an organization?
Yeah. So I mean, we have been doing R&D for this technology since 2016, actually. So it's almost 4 years before we launched our machine into the market itself. But even when we launched it, we didn't start selling the machines out, but we wanted to do a field testing with a closed group of clients, actually. So since 2019, we have been catering to clients as a services model. But these people knew that this is a fresh technology in the market. So we have been getting kind of a closed loop feedback system with them and also catering to them. But by this method itself, we were able to push components in the aerospace where some of our 3D printed components are being used by drones in Indian Navy, and some of the other fighter jet wind tunnel simulations also have been used in ADA, HAL. And it's like that we have been able to push in very serious aerospace and defense applications itself. We were able to penetrate during our field testing phase, actually. And that gave us a very good confidence on the quality of the products that we got. And after that, because of the pandemic, we again had to delay our launch plans a little bit. So now in February, just for 3 to 4 months back, we launched our machines into the public market. And we have got very good feedback since we launched the market also. Lot of sample requests that have also come back with very good feedback, and a lot of orders just started getting placed. And we are also onboarding resellers at this point to scale up our activities. In the initial days, we wanted to get a close feedback from our clients also, prospective clients also. That's kind of why we were also part of active sale discussions. But we will be like slowly signing off into just a reseller based fabrication, but we will be completely part of the after sale, like where the proper calibration has to be done on a regular basis and maintenance work has to be done. So here we do support our resellers completely, because we felt that is something that is lacking in the 3D printing ecosystem in India, where there are a lot of resellers, but not many of them do the after sale support. Actually, very few resellers actually provide the after sale support, and which is becoming a hindrance for the people also, like, because when people buy the machine and then they feel like the after sale support is not there, then that whole brand of it gets devaluated. So what we decided is, like, we will support our resellers, and we will offer to train their staff also to become part of the after sale activities. And even if they don't have that kind of existing infrastructure, we will provide that infrastructure to them and give them some time to cope up and catch up to that kind of setting up an internal infrastructure for that also. So that is kind of what we are doing right now. We are actively onboarding resellers. We have onboarded for a couple of geographies right now, and we are still onboarding a few more geographies. Yeah.
Fantastic. Now, a very ambitious thing to be then asked for, whether you're also looking at an international market also in the prospect. Is that also what you plan to do eventually with time?
Yeah. So we are looking at partners for our international scale up also. Again, I mean, like we right now in India, we are doing the after sale support for the time being. We will not be able to do that immediately for the international market. So we are looking at partners who can do that after sale support, because without a good after sale support, we don't want to start selling our machines on. That is something that, as a core belief, we believe that an after sale support system has to exist in a particular location before we start selling machines. So without that, I don't think we stand for that brand value that we want to bring into the missions, essentially. So we are looking for partners who can bring in that kind of support abroad, and we are identifying and doing some due diligence with few players right now. And we will be expanding globally also as we set up these infrastructures.
Also, Dhinesh, we also know that education is one of the key aspects for this technology, and colleges and institutes who also need to be updated on this technology. Though it's not new, many of the colleges now, engineering, have already got acquainted with this technology, and they've already even procuring these machines. Yeah. But still much to be done. So every day there is a new technology, there's a new systems that needs to be understood. What do you think about that as a prospect in the country for your machine and your technology?
Yeah. So one thing that we have understood is carbon fiber as a material itself is not very well understood in the industry today yet, at least not yet. We have seen many clients using the material, but even they don't have a very good understanding of how to use the material really well. And that is something that, again, that we understood during our field testing time that I talked about some time back. So in that particular time, what we did for our clients is essentially we not just told them that this is a new manufacturing technology that you have access to, but we're also part of educating them on how you can use this manufacturing technology to design your carbon fiber parts so that you can get the maximum out of it. So they have to redesign to suit this particular manufacturing process, because let's say you cannot have a sheet metal and a casting, two different manufacturing process cannot have the same way of design methodology, right? So in sheet metal has completely different design thought process, and the casting process has, and it's the same thing here also. So yeah, traditionally carbon fiber product has a completely different design methodology compared to what a 3D printing of carbon fiber has kind of a design methodology. So we are part of that particular training procedure that we do to our clients here. And even when we sell a machine now also, along with the after sales support, we actually take up 5 staff from each company that we sell it to, and we train them completely, not just on the operations of the machine, but we also train their engineers on how to use this manufacturing process and how to go about design thinking for this new manufacturing process. It is an active educational experience that we are offering to our clients, and we have to continue this, because in Indian ecosystem, at least carbon fiber or composites, it's a little nascent. And I mean, not just in India, for example, like, because carbon fiber, even across globe, if you see 1960s is when first it started out. Metals have been since there from 5000 BC, people have been casting parts, but carbon fiber as a material itself came only in 1960s, and people are still catching up to how to design components using this material actually. So that's kind of a teaching experience that we have, and we are also partnering with some colleges, some training institutes to train more people in this particular industry, so how we can use this particular technology by various clients also. For example, we have worked with about 35 drone companies in the past 1.5 years, and they all have, like, we have offered them a lot of knowledge transfer on how you can use 3D printing effectively in their development stage or in their actual final production stage also. Like that's something that we will be doing for other industries also in similar fashion.
Interesting. I mean, also when you talked about design for thinking, DFAM is very, very essential when it comes to the final construct. So the training is also been done by your team, Dhinesh?
Yeah, we do the training ourselves. Yeah.
Okay, that's nice. Because it's a complete different thinking in terms of, because we need to think, it's more like a backward thinking in terms of creating the final product in terms of what is expected. Because the conventional method is different in terms of CAD design, but here it is different. Yeah. Also, when it comes to the material composition, it's completely carbon fiber, right? As a material that is being produced. And is it being produced at your end? Are you also manufacturing these materials, Dhinesh?
Yeah. So the carbon fiber raw material is imported, but we procure it in a format that is like readily off shelf available, but that cannot be fed into the 3D printer. So that has to go through a pre-impregnation process, and that is after that only it can be handled by the machine. So we do the whole pre-impregnation process in-house. We have a separate patented technology for the pre-impregnation stage, and it's this pre-impregnated format that we give to our clients. So they can use it as part of a raw material directly in the machines. And this pre-impregnation machine and the material production process, we handle it in-house.
Okay. Yeah. So which means when you procure it, it comes in the filament form, or it comes as a.
It comes like a thread. You can imagine a thread. It comes like a more like
and
a thread.
And then it needs to be processed at your end in terms of smoothifying it or getting into that kind of a.
It becomes more like a filament after the process is done.
Oh, after the process. Okay. Yeah. So great, Dhinesh, for your inputs, and I'm sure the potential of this technology in the machine and the material has a great potential for various sectors. And I think, as you rightly said, everything has the first initial phase of gestation. But I know of the fact that there are many automotive companies who have already started procuring and looking at carbon fiber as a material. Because if you know about a company by the name Zinger, they are actually they are manufacturing cars completely 3D printed and also with carbon fiber, because that makes your car lighter, efficient, mostly in Formula 1 cars. because for them speed is the key, and also then the tensile strength in terms of what it can achieve. But I think many of these work is also happening in the aerospace, even for MROs to look at this as an option in aerospace. Even parts can be really looked at as an option. So when I'm saying in terms of scale and size, the maximum size you mentioned is to print this part would be.
So the machine that we have installed in our capacity in our facility right now caters to up to 1.5 meter size. But it is a very it is a very scalable setup.
There's a scalable setup.
Yeah. So the machine
Thank you so much, Dhinesh.
Installed is 1.5.
Thank you so much. I think you have a way big future ahead going forward, and wishing you a very, very successful venture. And I'm sure. I mean, indigenously manufacturing companies in India, we always feel proud of in terms of for the efforts made, because there's a lot of effort being made. You said that 4 years in terms of research, starting with services, and then finally coming up with this product, which means that you're here geared to go. So all the very best, and thanks for your time, and we'll keep in touch. Thank you so much.
Absolutely. Have a good day. Thank you very much. Thanks for this.